Today we are going to be talking about a calculator. This is an abacus. Anything I do today can probably also be done with this thing, which I find surprising. It can do addition, subtraction, multiplication, division. Apparently it can even do squares and cube and roots. Interestingly enough, I just checked the Wikipedia article. But that's not the topic for today. The topic for today you will see after I close this twice, and you can see what we're doing. We're not doing the old school calculator, but the new school one, the devil's calculator. And with that said, we are still on level 30. I have had massive problems on this level, and my current idea on how to solve this, let's make this so that you can see 5 zones. I think you should be okay. My idea is solving this by doing an equation system, a Gaussian equation system, I think. Equation system. And we're going to think that it's linear. The goal is the following. Right now I am assuming that our function is something where like an f of xy function, and it probably is made up of a sum over I and j, both let's say whole numbers for now, with x to the power of I times y to the power of j. That is what I think the sum will look like. For reference, this means, for example, f of xy could have the form x plus y plus x square plus y square. So we could have singular terms which only have one potency of x or y, or x times y, or x times y square, or x square times y square. We could have these mixed terms. That is, I think, a reasonable assumption, right? It's not too far-fetched. There is one thing that we've already found out in the last video, I think. If I go for 5, 6, for example, this is 342. If I go 6, 5, it's 342, which means this is a symmetric polynomial, which means I can write it in a specific way. I can use only symmetric monomes to represent this symmetric polynomial. For now, I'm not going to do that because it could really quickly escalate into something really big. What I want to do is also, this is an operation which connects two numbers. This psi, it connects the left number and the right number from the side. I am not thinking of this as an operation, but rather I'm thinking of a function which is f of xy equals x. Do we have a psi over here somewhere? X psi. Why does this never work? X psi y. That is the way that I'm interpreting this. Now what I am going to do is I am going to make the one of the two functions f of xy. I am thinking of f of xy as f given y of x, meaning I'm going to choose a number for y, which I'm going to keep constant, and I'm going to try to represent this entire thing as a function that is based on x, a polynomial that's based on x. And for that I'm going to be doing a linear equation system. For now, A, B, C, D, E. I'm going to go for 5th degree, and F is then the actual, you will see what I'm talking about, hopefully. I think I'm doing this correctly for now. It's been a while since I've done this. Okay, we are going to be going for let y be 0. And in case this doesn't work, then I just have to think of this again later on. So we are starting off with 0, 0, which is 1. We know that e is 1. So no matter what happens, it should be 1. No, yeah. We're going to go for, wait, just one more check. Yeah. First mistake. It's not 1, but it's 2. Nope. Okay. You can see I'm not really the smartest guy in the world, okay? 0, 0, 1. Okay. E is 1, F is 1. Yeah, I need to do this in a bit different way. A plus B plus C plus D plus E equals 1. Yeah, okay, now I remember. Alright. It's just been such a long time. 0, 0, which means 0, 0, 0, 0, 1. How do you read this? It's basically a times x to the power of 5. We input 0 for x, which is 0. 0 to the power of 5 is still 0, plus b times x to the power of 4. Once again, we input 0, which means we have b times 0, which is still 0, plus c times x to the power of 3, plus d times x to the power of 2. And also, yeah, I just made a small mistake. It starts with 4 and not 5. This is 3. I wanted to go fourth order because that's easier for now. Alright. We are finally up to speed. E1. Now, we are going to go for... What did I want to go for? Let me think for a second. Right. 1, 0, 2. Which means this is a 1 because 1 to the power of 4 is 1, to the power of 3 is 1, to the power of 2 is 1. So all this. And if I'm correct, I think we just keep the 1 over here as well. Once again, it's been a really long time since I've done this. Next, 2. 2, 0, 9. Also, we do need to put the 2 right here. This is the 9. You know what? I can just do all of them right now. 3, 0, 28, 4, 0, 65. Now we just input the things that we suppose 0, 1, 2. So 2, 4, 8, 16. 16, 8, 4, 2. It's really been a long time. I need to refresh these things. Lastly, 3, 9, 27, 81. 81, 27, 9, 3, 1. One more. 0, 1, 2, 3, 4. A, B, C, D, E. Okay. 4, 16, 64, 256. 64, 16, 4. We now have a matrix system, or yeah, we can call it a matrix, which we can now use to calculate the values of A, B, C, D, and E, given that Y is 0. We can do that in LibreOffice. I have never done this before, but equals matrix mults. I did make a tab to check what it's called, so I'm going to look that up. 1 second. In LibreOffice, it's called right here. You go for the coefficient matrix M mult minverse A B. Okay, this right here should be it. Hopefully. And then I need to actually fill these things out. This one needs to be, well, the F, what F is actually at, what, this one is the entries for F, which means 1, 2, 9, 28, 65, right? No, we need to separate them using apostrophes. Yeah. Next, we need to input A, which is 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 3, 4, 5 here. 16, 8, 4, 2, 1. 81, 27, 9, 3, 1, and the last one, 256, 64, 16, 4, and the 1. No. Apparently this does not work. In that case, I will probably need to... What's this one for? This one isn't needed. Still not working. Mult, minverse, matrix inverse. I want the inverse of A, which is 1, 2, 3, 4. This is A. I want the inverse of this one. If this is not a fourth order polynomial, I would need to get rid of this and this. Maybe it's just a third order polynomial, so let's get rid of all of this. Well, this will also ease up the actual equation just a bit, and apparently, well, it autocorrected even though I said it should not autocorrect. Alright, this one needs that, 16, 8, 4, 2, 1. We need this one, and it's still not working. Once again, it might just be a problem of the order, so let's do this again. And we are going to get rid of the 28. Next we are going to get rid of these last 4 numbers, and we are going to, once again, it auto-corrected on its own. Still not working. In other words, I'm making a mistake here. Well, I'm going to find out what it is, and we are going to see each other again once we're done. Alright, this took a bit longer, so I just had to do this in a bit with a bit more time for myself. As you can see, we haven't really changed much from the matrix. This is the matrix. This is the part you can write any equation in an equation system as a times x plus b equals c. In this case, we have a linear operator, which is why we have this as the equation, a times x equals c. And as you can see, I did 2 things. First of all, I used the matrix inverse operation. In order to solve this for x, you need the following. You do x equals c times a inverse from a different side. You multiply from the left and not from the right, because in matrix writing with the order matters. So this one, a inverse times c, and this is a big X. This is also a big X. If you do that, you can get your solution for x. Right now, what we did was we inverted the matrix using minverse, and we then just selected this much of a matrix, which is the A part of the matrix. This is the C part of the matrix, and the X part of the matrix is A, B, C, D, E, even though they kind of overlap, but that's what we call them, whatever. And that is what we got. Basically, what we now did was we also wrote this down. This is X, not X, this is C, which, okay, no. We will wrote this one down, which is the multiplication of A inverse, and F19 to F23. This is C, and this here is A inverse. And what we got was this expression. What this means is that our function looks the following. Normally we have it somewhere right here. This was the function that we started with. We now know that A is 0, we know that C is 0, and we know that D is 0, and we know that E is 1, as well as B is 1. So that is the expression that we get, which is x cubed plus 1. And I have already checked. If you check 666 and equals this to the power of 1 divided by 3, you get this expression. Since we can't use comma, I just checked 8 psi 0, which is 513, 9 psi 0 is 730, so we are already really close. what we now need to do is probably check the we do the same thing. Instead of 0, we go for example, we go for y equals 1, y equals 2, y equals 3. That's the goal. And right now, before we do that, I just want to show to those people that might not actually know how to solve an equation like that. I just did that by hand. This is the equation. We have a matrix system. I can also write down A, B, C, D, E, and F. This is the number of lines that we have. This is the first line, second, third, fourth, and fifth. You write down here the operations that you want to do. You subtract the first line from the second line, from the third line, from the fourth line, and the fifth line. If you do all that, you get this. And what that means is I have reduced this order 5 linear equation system to an order 4, where we don't look for E, instead we just look for A, B, C, oops. We look here for A, B, C, D. This is now the E spot that is now empty, and this is F. Once again, we redeclare line 1, line 2, line 3, line 4. We subtract 2 times the first line from the second, 3 times the first line from the third, 4 times the first line from the fourth. So that right here, these lines will become 0. Meaning 2 minus 2 times 1 equals 0, 3 minus 3 times 1 is 0, and so on. Right now we're trying to make this 0, then we're making this 0 and this 0, which is, I think, Gaussian Pyramid solution scheme. I don't know what it's called in English. Anyways, this is the ansatz we're doing. Right now this is what we get. Once again we redeclare. We once again subtract with the second line this time, so that we can get these two to 0. We get this. We subtract from the third line, we get this. From this we can then once again subtract the third line. We get we learn that A is 0. We reduce the linear equation system to an order 3. This is the system. Can I do one more? Yeah, this. Next we are reducing it to order 2. We now know, I think we learned this should be C. No, this should be B. This should give us C equals 0, and this should give us D equals 0 or something. And then we get that our solution is just this. Anyways, we did this. Now we need to actually do the whole we now need to write this calculating spreadsheet around, so that we can actually do this a bit more automatically instead of always needing to do this in a slow way. Let me think for a second and I'll come back to you. Alright, I just basically pasted the entire thing so that I can easily change these things. So for example, I have y equals 14. I would go for 0, 14, 2, 7, 50, 45. 2, 7, 45. I would go for 1, 14, 2, 7, 46, and so on. We are not going to start with 14. I just tested this out. 14 is too high. We can already see that, so we will just delete the 14. Let's check y and 10. Also too high. Y and A, it doesn't really matter which order we put them in. Okay, 8, 0, we can talk about 8. 8 is probably the maximum what we can do, so let's get rid of all this slowly, so that I don't just so that my thing doesn't just speed up and delete more than it should. Alright. This is the maximum that I'm now going to fill out. I'm doing this. You will see me after a short cut, and then we will see what we get. Alright, small change of plans, because I noticed something pretty simple, but I wanted to make sure. When I did check some things, and I noticed This is the original values we got for y equals 0. This is the thing that we got as a result. This is the thing we get for y equals 1. This is the thing we get for y equals 2. And it continues like that. I could continue like that, whatever. And I do have a hypothesis that by going for x cubed plus y cubed plus 1, that we would get all the answers with that function, that our function looks like that. And I did try a few things. This is the first thing I tried, just to check which cubics of 666 we could use to get a proper result. For example, this one seems pretty interesting. But yeah, this is the actual thing that I wanted to show. This is x and this is y. It doesn't really matter which one is which, to be honest, but yeah. And by making this program code, so it's not really a program code, but by this right here refers to, one second, this right here refers to B377, which is the blue one. And by making this $sign, I am making sure that if I go down, one second, I need to think about this, which one refers to which. Yeah, correct. If I go down, it doesn't change by copying this, copy pasting this to the entire table. It does not change the fact that we are still in row 377 and this $sign in front of the A378. If I copy this to the right, it does not change the fact that we are still in column A. This is my hypothesis. It basically reads x cubed plus y cubed plus 1 as our function, and I just checked some random numbers. For example, this one, 9 and 10. 9, 10, it fits. I did check some other ones. We can also do this one. Oh. 1 second, it's back. All right, 4 and 7, I think. 4 and 7, yeah. And this is our table to do these things. Now we have a table, and now I need to think about how we do this, because it, as you can see, or maybe you can't see because there's just so much content on here. If I check for number 666, right here this is the last 666 before that table. If I go down, I'm back at the beginning of the document, which means there is no 666 in here. How do we solve this? I have a pretty simple idea, and we're going to do this. Basically, we copy this right here, and instead of having a 1 as the starting point, we start with -1, -2, and we copy things until we are right here. Now we have a lot of negative numbers and a lot of positive ones, and right here we have something. Let me do this one, 9 and -4. 9, -4. How much time did this take in this recording alone? 28 minutes. I did a lot of off-screen things too. So basically, what did we do? First assumption. Step 1, this was our ansatz. F of x, y equals a polynomial of x and y. First ansatz, pretty fine. Next, we set y as a constant, and we solved the polynomial for x. We did this by doing a linear equation system of, I think, 4th degree. We found out it was a 3rd degree polynomial. 3rd degree. I can make this a bit larger. 3rd degree polynomial. Can you even see this, what I'm typing? You can't, interestingly enough. Okay, now you can. Alright. If you can't read this, I don't know. 3rd degree polynomial. which was x to the power of 3 plus 1. This was step 2. Step 3. What did we do in step 3? We solve the equation system for multiple y. So we did a variation of a constant y, which gave us insights into the behavior of a function when y changes. Step 4. We analyzed the behavior of f of xy with varying y, and this resulted in behavior symmetric to behavior of x. So basically we found out, we changed right here from here to here. I need to from this one, y equals 0, to this one, the degree of x did not change. It's still x to the power of 3 plus a constant. And since we did know that it was symmetrical, f of xy equals f of yx, we could have already surmised that y would behave in a similar way, which means we have a symmetric polynomial. This means our polynomial contains the symmetric polynomial of third degree, x to the power of 3 plus y to the power plus y to the power of 3 and a constant, which we did know was 1 through our first calculation, and this resulted in us finding out what it was. I think I overcomplicated this a lot. First off, I could have started with a third degree polynomial, because fourth degree is already a bit much in my opinion, and I don't think that the Devil's Calculator would go that far. Second, I did not use the fact that f of xy is symmetrical, and instead I had to manually do all these until I think y equals 2, that I was fully convinced that that was the case, which meant it wasn't efficient. Those were the two things that I lacked in this time. Let's continue our little game with level 31.